Alright, let's look at the homework 4.1, problem number 2. Alright, we want to find the critical numbers of this given function. Alright, so the easiest way to do this one would be, first we're going to visualize the graph. We know that this can be rewritten as, I'm going to pull 6 out, so you have a 6 is outside, then t. Right, if you pull out 6 from -1, so it's going to be -1/6. Right, so we know how to sketch this guy because you can apply two transformations to the absolute value function. So first transformation is this times 6, so it's going to be a vertical stretch by a factor of 6. Then we just shift the whole graph to the right by 1/6 unit. Alright, so we're looking at a graph which looks like this. Right, so originally, absolute value of t function, it would look like this. So here's the t-axis, say here's a y. Then the graph is it's looking like this originally. So this is the absolute value of t. Right. Right, so the first transformation would be multiplied by 6, so it's going to get steeper, so I'm going to just draw it kind of like this. Right, and so it's going to have vertical stretch like that, and then it's shifted to the right by 1/6, so I'll just put the 1/6 there. Alright, so the graph is going to look like somewhat like this. Alright, then remember that in order to be a critical number, derivative has to be either 0 or undefined. You can see that along here, derivative is going to be always negative because it's going down, and along here the derivative is always positive, so it's not going to be 0. Alright, the only place that could happen would be right here. Right, you can see that there's a sharp corner, which means that the derivative doesn't exist there. So which means that when t equals 1/6, then derivative doesn't exist. So we know that g prime of 1/6 and is undefined. Right, which makes t equals 1/6 a critical number. Right, so let's type it in, and this is going to be 1/6. Right, let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.